Hi. Thank you very much for not being here. Um, I'm Michael Bolton. I'm in my office right now, and this is kind of unusual for me as a speaker because I'm not standing up. I'm not in front of a crowd. In fact, you look like this, and you can see why I would find that a little bit disconcerting. Anyway, today we're going to talk about 4 frames for testing and 3 stories to tell. One of the things that bothers me about the state of the world today is that in our relentless quest for automation and tools, we're not really thinking about the heart of testing, what our clients need and what our customers want. It seems to me to be a really good idea to think about that. So let's start with that. What does a business want? The business wants a high value product. That's how it keeps customers happy. That's how it makes money. And in doing that, the business is envisioning success, wanting to get something done. So, people hired by the business build the product. And that's how the business gets something it can sell. To build a product, the people focus on the bits and pieces, the components, they put things together, they invent new things, and they get them ready to deliver to the customer. Now, while they're doing that, the business is concerned about something else. The business wants to keep the cost of development low. That helps to make the business sustainable. Now, through the course of building something complicated, there's always the possibility of failure, and we anticipate that. And in anticipating failure, we study what we built in order to find out whether the business really got what the business really wanted. And that's a process of defocusing, of taking the bigger perspective on the product and the things in it to see if we have achieved the goals that we wanted to achieve. Well, I bet that sounds great to you. Sounds great to me. What could possibly go wrong? Well, we can think of 4 prominent kinds of business risk. We might not be clear on what the customers would want the product to do, and partly because of that, and partly because of what technology is like, we might not be clear on how to build the product either. As we build the product, we might be committing easy to find and avoidable errors as we try to build it. It might be hard to know what to build, it might be hard to avoid those errors, or it might be hard to identify deep problems in the product. And that's important because there might be bad problems, hidden problems, subtle problems that escape even a highly disciplined development process. That's where the risk lives. So what's the testing role? What are we as testers here for? Why do we test? We test, above all, because the business wants answers to 2 key questions. Number 1, what is the actual status of the product? The business wants to know how the product is doing and whether the product is good. And the business wants to know if there are problems. The business wants an answer to the question, are there problems that threaten the value of the product or the on-time successful completion of the project? That's what the business wants, and testing is how we find out about those things. So if we wanted to address those business risks that I spoke of earlier, what would we do? Where would we focus our testing? Well, when we're not sure on what the customers would want to do or how we'd want to build the product, we would focus on intention. Design-focused testing and review that can help us to discover what the customer really wants. Then we move to the area where we might be committing easy-to-find, avoidable errors as we try to build the product, and to address that, we would focus on disciplined development. Now, I'm not talking about enforcing discipline. I'm talking about things that enable discipline, enable us to produce a product smoothly and quickly and easily, with review, with pairing, with shallow testing and low-level output checking that can help us to confirm that what we've just done is reasonably close to what we intended to do. As we anticipate failure, we focus ourselves on advocating for practical testability. That is, all the things that make the product faster and easier to test, organizing our product, our project, and our systems to make testing easy and to help us test efficiently. We must anticipate those problems that could escape our discipline. And so we focus on deep testing, getting experience with the product to help us discover hidden, rare, subtle, intermittent, platform-dependent, surprising, emergent problems that would get in the way of people's needs and desires for the product that we're building for them. So if the business wants to sell a high-quality product, high-value product, what do? Well, it seems that a reasonable thing to do would be to discover something worth building. And then we would build some of it. Since we want to keep value high and development cost low, it would be a very good idea to build it virtuously. And then once we built it, just in case there are problems along the way, we should study what we've built. Now, I'm going to offer you a model of development here that's a little bit of a straw man. You'll probably forgive me for that. I won't have been the first to have done this. In the traditional development cycle, we would discover something worth building, and over a period of several months or maybe even years, we would build almost all of it. That's what building some of it means in the traditional development cycle. And because it's a big project and there's lots of stuff to manage and we don't know exactly how we're going to build it, we would try to get it right the first time. And in order to do that, we would make development ponderous and slow and expensive. The cost of change would be very high. When it came time to study what we've built, well, that would be slow too. We would be focused on documents and artifacts and preparation, and after a fairly short time, we would discover, there's lots of bugs, because we haven't been looking at the product all the way along. We've separated development into a programming phase and a testing phase. Well, at that point, discovering something worth building would mean discovering something worth fixing. After the first long loop, we would have a few short, panicky ones, and the cycle would begin, this time much more rapidly because testing is under pressure, because the developers used up all the time earlier in the schedule. And then, one day, like the cavalry coming over the hill, along came the Manifesto for Agile Software Development. Huzzah! In the Manifesto for Agile Software Development, a group of programmers mostly who decided to take responsibility for the quality of their own work uncovered better ways of developing software by doing it and helping others to do it, they said. Through this work, they said, we have come to value individuals and interactions over processes and tools, working software over comprehensive documentation, customer collaboration over contract negotiation, and responding to change over following a plan. They weren't abandoning the things on the right. They said, while there is value in the items on the right, we value the items on the left more. Certainly there's no lack of enthusiasm for processes and tools in agile software development these days. You can look up the original 4 aspects of the manifesto and 12 principles associated with that at agilemanifesto.org. What would the landscape of that look like? When James Bach and I were developing this way of thinking about testing, we decided that we would cherry pick just a few items from the principles for agile software development. We chose these ones. Our highest priority is to satisfy the customer through early and continuous delivery of valuable software. In other words, focusing on high value of the product. And because we want to be responsive to the needs of the business, we would welcome changing requirements even late in development. Focusing on the low cost of development, we picked this item out of the principles. Continuous attention to technical excellence and good design enhances agility. So that's the top and bottom of our diagram. I want to draw your attention to the left and right, the building focus on the one side and the testing focus on the other. That becomes important as we move our way through the agile development landscape. Given a set of ideas and principles like this, what would testing look like? In an agile context, individuals and interactions over processes and tools would suggest focusing on the skill sets and the mindsets of people who are doing the testing. Working software over comprehensive documentation would cause us to eliminate wasteful documentation and emphasize investigation and learning and discovery. Customer collaboration over contract negotiation suggests focusing on the project and the needs of the clients and the business. And responding to change over following a plan would be, in testing, responding rapidly to its ever-changing mission. That's one of the constants we have to face in testing: change. So contrasted with the traditional software development landscape, the agile development cycle looks like this. Over short cycles of disciplined development work, we would not build almost all of it, we would build almost none of it, and do inexpensive, shallow testing as we go. We would respond to change, and we would respond to our tendency of human beings to make errors by building the product cleanly and simply, and by preparing to make deep testing less expensive. We would build with change in mind. In order to study what we built, we would perform deep testing to discover problems so that they could be fixed before they're buried and inflicted on customers. And that would mean that discovering something worth building also meant discovering something worth fixing from time to time. We would build in lots of short loops to avoid getting ahead of ourselves, to get quick feedback, and to help ourselves maintain a sustainable pace. Sustainable pace is something that's got lost an awful lot in the agile development landscape these days, or so it seems to me. Now, I want to pause for a second and explain to you what I meant a moment ago when I referred to shallow testing and deep testing. Shallow testing is testing that has a chance of finding every easy bug. Now, that's not an insult. Shallow testing helps the developers to make reliable progress without slowing down development work. And testers need to start with shallow testing in order to learn the product and get to deep testing. Deep testing is testing that maximizes the chance of finding every elusive bug that matters. And deep testing takes time. It takes effort. It takes determination and commitment. It takes a shift of mindset away from the builder's mindset and into the critic's mindset. And as such, that can be pretty disruptive to developers who want to make progress on building new features quickly. The issue is that when there's risk, we need deep testing. We need deep testing to find problems that we might have missed with shallow testing. All right. Back to agile development. What does it mean to do agile development? It seems to us, to James and me, that doing agile development would mean delivering often so that we can evaluate the product efficiently and so that we can get fast feedback on it and we can give it to the customers to evaluate sometimes and we can deploy it anytime we want safely and reliably. Doing agile development means collaborating across roles to take advantage of ranges of expertise across the team. It means developing craftsmanship, After all, one of the Agile principles is attention to technical excellence and good design enhances agility. We would avoid excessive formality in Agile software development because formality is expensive. It slows us down. It makes things harder. We have to do things in a particular way. Well, that's often unnecessary. Much of the time, our testing at least doesn't have to be too formal. But when we need formal testing, we're happy to apply it. We would apply appropriate heuristics. Heuristic is a fallible way of solving a problem or a fallible way of getting something done. When we're building something that's new, some degree of confusion and some degree of innocence and some degree of ignorance and some degree of naivete, and therefore mistakes, all those things are normal. They're not maybe desirable, but they're normal. So we should be prepared to try stuff and periodically to fail, but to fail as briefly as we can and learn from the mistake and move forward. In Agile development, we would develop and apply tools to help us get our work done and to help us test, to help us find errors quickly, to help us investigate and probe the product for deep problems. We would maintain a sustainable pace. Sometimes I hear about testing getting swamped in Agile development, and I don't like the sound of that because it means that we've lost another one of the Agile principles, which is that a sustainable pace should be achievable for the project. And if there's too much work for anybody on the team, including the testers, then by definition the pace isn't sustainable. Now, in rapid software testing, we are pretty strong advocates for the role of the dedicated tester. But in an Agile project, everybody's responsible for testing. Do we really need dedicated testers? I think so. And let me tell you why. There are 4 kinds of testing work, as we've said. And 3 of them are being done by people who are mostly builders of the product. That can affect their approaches to testing. When people are focused on developing their intentions for the product, it's an optimistic moment, and they often sweep the idea of failure aside. It's our role as testers to notice things that could go wrong and to ask for testability in the product. And that's not always on the agenda for people who are focused on building and getting the product done. Developers love to program. Lots of testers do too. The kinds of things that we see in the discipline frame, the review and the shallow testing and the low-level output checking, developers sometimes think that this is all there is to testing. But if we think about it, this is checking the components and it's checking the build. It's not exercising the entire product in a way that testers might do later on. There's a big difference between checking the build and testing the product. Lots of people who are involved in building the product are fascinated with technology. Rather fewer of them are focused on testability. That is, the aspects of the product and the project and of the tester himself or herself that makes it easier and faster and more valuable to test the product. That doesn't happen by accident, and not a lot of people are strong advocates for it. Very few developers indeed, and maybe too few testers as well, have the determination and the skill and the patience to test a product deeply. And some people carelessly dismiss this kind of work as manual testing. I want to speak about that for just a minute. When a lot of people are focused on building the product, there's the potential for a kind of overfeeding of one kind of testing and a starvation of another kind of testing. Maybe there's a little bit too much focus on the developers' approaches to testing, and maybe the designers, and maybe the infrastructure people. And maybe there's not quite enough focus on this, on the realization frame, on the deep experiential testing. not manual testing. Not manual testing? I hear your plaintive cry. I think that when we talk about manual testing, we testers are shooting ourselves in the foot. Manual has lots of connotations about rote work, about grunt work, about stuff that you do with your hands. But as Cam Kaner famously said, you don't test with your hands, you test with your minds. So, let's take manual testing and replace it with a term that I think covers the territory much more richly. Let's talk about experiential testing. What would that mean? It would mean interacting with the product in a way that reflects the way that people actually use the product and get experience of it in its natural context. Experiential testing would emphasize exploration, discovery, investigation, and learning. And it would reduce emphasis on confirming that everything's all right. In experiential testing, we would use all of the normal information sources and all of the oracles that we use to recognize a problem, but we would also take advantage of the tester's entire range of feelings and experiences with the product. We would apply a minimum of mediation, things that get in between the tester and the naturalistic experience of the product. Now, what does that mean for somebody who is a data entry clerk? It would mean using the product as a data entry clerk would. For an API, it would mean using the API as a programmer would use the API. It would mean interacting with the product and encountering the frustrations and the confusions that people are normally encountering when they experience something new. And we would be learning from that experience. In other words, what we're talking about is remembering to use the damned thing. Sometimes people talk about social scientists of a certain sort in a dismissive way. They talk about people as armchair anthropologists. We need to be careful that we reserve some of our testing focus for stuff that is not mediated, that is not overly instrumented, that is not what you might call armchair testing. What I'm saying is our approaches to testing can't stop at checking the build and confirming that everything's okay, because that's only an appearance of okay. We must interact with the product in naturalistic and uninstrumented and unmediated ways so that we understand the user's experience of the product. See, the trouble is, approaches to software development and to testing are dominated by a programmer's mindset. But the programmers aren't the people who use the product. It's good for them to check their product carefully. But as David Platt is fond of saying to programmers, your user is not you. What worries me is that in many places, agile testing is dominated by programmer-like and programmer-focused approaches to testing. Low-level output checking, using machinery in order to interact with the software, which has its usefulness. But it ends up with a sort of vitamin deficiency if we don't engage with the product, if we don't get our hands and eyes and minds on it. Testing needs to be focused not only in the intention and in the discipline and in the preparation frames, but it also has to pay attention to the realization frame. There can be lots of problems in the relationship between the product and the people who are going to use it. And we don't know what those problems are. And we don't know where the product risk lives. Except we do know that product risk leads to business risk. In order to find the problems that matter, we need experience with the product and experience of the product. So I'd like to offer you a heuristic, a fallible way of solving a testing problem. And it's in the form of a lens that we can zoom up or zoom down to look at the product and the project at any level of granularity we like. 4 questions applied to each one of the frames. For the intention frame, the question is, do we know how this thing should work? For the discipline frame, are we building what we think we're building? For the preparation frame, what must we do to be ready to test efficiently? And for the realization frame, do we know about every important bug? We can train those 4 questions on anything about the product or about the project. And here's why. Although we talk of timelines, projects aren't really linear. They're not circular, they're not even loopy. Development is a fractal. Development is composed of bursts of activities inside bursts of activities that are themselves contained inside other bursts of activities. And we can look at the product at any level, and we can apply those 4 frames and those 4 motivating questions to any level of granularity that we like on the product or the project. What might be a little tricky to wrap your head around is that we can apply these 4 questions not only to the product and the project, but to our testing itself. Do we know how this thing should work? Are we building what we think we're building? What do we have to do to be ready to test efficiently? Do we know about every important bug? We can apply that to our testing in the intention frame. We can apply those 4 questions to the discipline frame too. The same 4 questions, those 4 questions to the preparation frame. And naturally, we can apply those 4 questions to the realization frame as well. Testing is a fractal. Now, I said that we can apply these 4 questions and these 4 frames to any kind of burst of testing activity that we might do at any level of granularity. Let's see some examples of how that might play out in practice. We've got a new feature in front of us, and we're going to be engaging in testing activity all the way through. What does that look like? Well, in the intention frame, we'd be, as testers, advocating for testability. We'd be analyzing whiteboard diagrams with the developers, and we'd be asking penetrating questions about them. The diagrams, not the developers. We'd be interacting with prototypes that the designers might have handed to us. And if we really wanted, we could apply given, when, then, or as a I want to so that I can, if you really, really want to do that, to help focus our intentions. I think we could do that just fine informally by asking 4 questions like this. What is this thing we're building? Who are we building it for? What could go wrong? And how would we know? As the programmers are building the product, that's where discipline-style testing activities come to the fore. Pair programming, where the developers are getting constant feedback on the product from each other as they're building it. Technical reviews, unit checks, frequent building and integrating at higher levels with low-level automated checking, and fixing bugs before we move on to add new features or sub-features. That's kind of important, because one of the things that really slows testing down and makes it harder, paradoxically, is bugs. When there are bugs in the product, the testers have to slow down and investigate and report them, and that takes time away from new coverage. Moving into the preparation frame, we would be creating and maintaining build processes. We would be setting up representative environments and realistic data. The developers would be helping us out by providing us with useful information on what's changed recently. As testers, we would be engaging with the product and learning about it, getting ready to test it deeply, developing test tools, creating test data, learning about the product, developing coverage maps, coverage models, so that we could approach the realization frame and get into deep testing of that feature. Experimenting with the product under realistic and naturalistic scenarios and getting experience with it. Stressing the product out. Applying tools, not just to run automated checks. In fact, I would recommend very little of that. I would use tools to amplify our testing superpowers, to help us to probe the product and investigate it deeply, to help us perturb it with extra variation, to visualize the output that we're getting from the product and use that for analysis, and using tools as well to help us keep ourselves organized and to report. So we're not against using tools, not in any way. But let's not kid ourselves. Tools don't do the testing, and automated checking, especially at the GUI level, which is kind of unfriendly to tools, is tricky and fiddly and time-consuming, and it takes a lot of maintenance. Let's try using our lens with 4 frames in the context of a design session. Now, in a design session, we don't have access to the running product. It hasn't been designed yet. We try to gain experience with the design, and we try to perform thought experiments on the design to help refine it and to help find problems in it. We would ask, are we clear on what the customer wants? And if we think we're clear on that, how do we know, and why are we so sure? Are we thinking about what the customer values? Because if we know about that, that can help us to focus our testing on the important stuff. And are we organizing the project in ways that will help testing go faster and more easily? In a design session, we would raise questions about the developer's plans and intentions for logging and scriptable interfaces in order to help us focus our discipline and to provide intrinsic testability, stuff that's built into the product that makes it easier and faster to test. Another thing we would want to ask ourselves is, how can we avoid building bugs into the product? Paradoxically, one of the things that slows testing down and makes it a lot harder is bugs. That's because when we encounter a bug, we're obliged to investigate it and report it. And that takes time away from obtaining new coverage. So one of the things that we want to do in a design session is to help focus the design on intrinsic testability, stuff in the product that makes it easier to test, that makes it easier for us to pump data through it, that makes it easier for us to exercise it. In a design session, we would be asking what we would need to do in order to get ready to test this design efficiently. In rapid software testing, we have a notion called epistemic testability, which is about the risk gap, the gap between what we know and what we need to know. In the case of a design, if it's a new design, or if it's got new elements to it, or if the designer is working in a new domain, then the product is going to be somewhat harder to test than it would be if the designer were working with familiar components or were in a familiar space. Similarly, we have to ask ourselves about subjective testability. Are we as testers in a good position to test this? Do we know enough about design, and do we know enough about the domain and the place where the design will be applied? If we do, then our subjective testability is high, and that's good. We can apply our testing lens to testing itself. We can apply our lens to the realization frame. Let's say that we're engaged in deep testing of a product. We would ask ourselves about our intentions. Are we focusing on gaining experience with the product such that we maximize the chance of finding every elusive bug that matters? Are we continually refocusing on risk, problems that will threaten the value of the product or the business? Are we taking lab notes to a good, credible professional standard? And are we offering up our work for review or evaluation so that other people can help us to investigate the product deeply? Are we getting feedback? In terms of preparation, when we're looking at deep testing itself, we could ask ourselves, have we prepared using data that is representative of the kind of data that the product is going to encounter in the world? Are we developing tools to help us probe the product deeply? Have we studied the product? Have we prepared coverage outlines? Have we studied the users carefully and gained access to them? And as we train the realization part of our lens on deep testing, we would ask ourselves, are we aware of any important problems in our deep testing? What problems might remain in our coverage or in our oracles, in the means by which we recognize a problem, such that we might still miss an elusive bug no matter how disciplined we've been? Will our reporting be credible and legible, readable and understandable to our clients? To test is to tell a single story in 3 parts, a story whose components weave around each other. We've got to tell a story of the product, about the status of the product, what it is, what it does, how it works, how it doesn't work, how it fails, how it might fail, in ways that matter to the business, our clients, and to their customers. That's a story about problems. That's a story about risk. That's a story about bugs. Now, in order for that story to have a warrant, that is to say, in order for us to have evidence by which we can back up our story, we've got to tell a story about how we tested, how we configured, operated, observed, and evaluated the product, how we recognized problems, and why those problems matter. That is a story about oracles. An oracle is a means by which we recognize a problem. And it's a story about coverage. Coverage is how thoroughly we've examined the product with respect to some model. We want to talk about coverage because we want our clients to understand what we've tested so far and how thoroughly we've tested it. But we also want them to be aware of what we've not tested yet, or what we might not test at all unless something about the situation changes. And that's important because that's where the risk lives, in the areas of the product that haven't received sufficient coverage so that we know enough about the product to make an informed shipping decision. We must also tell a story about how good our testing was, or about how good it could be. A story about why the testing we've done so far is the most fabulous testing that we could possibly have done, or to the degree that it wasn't, why it wasn't. What got in the way? What made things harder? What made our testing less valuable? And that is a story about issues. In rapid software testing, a bug is anything that threatens the value of the product to some person who matters. An issue is anything that threatens the value of the testing, anything that gets in the way of testing, that makes it more difficult or more time-consuming or less valuable or informative to our clients. That third strand of the testing story also includes what we would need or recommend in order to make our testing even better, faster, more high value, easier, so that our clients can get the information they need to make an informed decision about whether the product they've got is the product they want. So that's it. That's the end of our little journey today. Happy testing. And remember, it's all about the people. And if you'd like to reach me, I'm Michael at developsense.com. I'd love to hear from you. Thanks a bunch. And thanks to the organizers. Adios.